Welcome to EDU World Space.
So you have a gas at 25 Celsius, so this is our temperature, which is confined to a cylinder with a movable piston. So let's draw that out. So we have some cylinder and then some piston, something like that. Okay. So our gas is somewhere in here. Okay. So which of the following the gas pressure? So for part A, we have that lifting up the piston. So if we lift up the piston, we're actually increasing the volume of our gas. Would lifting up the piston double the volume while keeping the constant, and then T is constant. So if piston, we are creating more, right? So now our molecules have more space to move around, which means that our pressure or the amount of molecules that hit a certain surface at a certain time would now be less. So in this case, it wouldn't double the pressure. In this case, it would actually decrease the pressure by some amount. So this is not correct. With heating, the temperature rises from 25 Celsius, so increasing the temperature from 25 Celsius to 50 Celsius, while keeping the volume constant. Would that double our pressure? If we heat or if we increase our temperature while keep constant, then our molecules are now moving at a relatively higher speed. In this case, since we're increasing it by, let's say, 25 Celsius, are we actually doubling our pressure? So we know that PV is equal to nRT. We said that our volume is constant, and the only things that are changing is our pressure and our temperature. So let's solve for P. So P is equal to nRT over V. We know nR over V is a constant, so we know that P is directly proportional to T, right? So if we were to actually, this is 25 Celsius, but let's convert Kelvin, because when we're using our ideal gas equation, we need to work in absolute temperature, which is Kelvin. So we know that 25 Celsius is equal to 273 plus 25, which is equal to 298 Kelvin. And then with your 50 Celsius, 3 plus 50, that gives me 323 Kelvin. 298 by 323 by 298. We see that we're increasing our temperature, but not by double its amount, right? Because if we were to double our temperature, this would actually be 2 times, give me 596 kelvins. So we are increasing our temperature, resulting in an increase in our pressure, because pressure is directly proportional to temperature, but we're not increasing it enough, so it doubles our pressure. All right, now for part C, we have pushing down on the piston to half the volume while keeping the temperature constant. Okay, so before, let's draw out our container. Before, our container looks something like this, and we're asked to push down on our piston to half the volume. So something like this. And then we're keeping our temperature constant. So this is our volume, and this is 1/2 of our volume. Okay, so let's look at our ideal gas equation. Let's solve for P. Okay, So we know in this case that our T is constant and so are N and our R. So we know that pressure is inversely proportional to our volume. We say that our volume is decreased by 1/2. So this is 1/2 our volume, which means that we have P is directly proportional to 2 over V. Actually, maybe that's not a good way to look at it. Let's read about it intuitively. So if we're decreasing our pressure our volume by 1/2, then that means that our increase or double. This is because we're keeping our temperature constant. So if we push down on our piston, we have the same number of gas volume. They're hitting the walls much more since our volume decreased. So in this case, if we double our pressure, you know that's inversely proportional to 1 over our volume. So that means we have to double our pressure.